June 14, 1944. Nagoya, Japan. The morning sun glinted off the massive aluminum wing section being wheeled into the Imperial Japanese Navy's Metallurgical Laboratory. Chief Engineer Takeo Yoshida watched with anticipation as his team prepared to analyze what was to them a technological marvel. The Americans had only begun high-altitude bombing raids over the Japanese mainland months earlier, and now the Japanese had their hands on a pristine piece of their adversary's most advanced aircraft. Little did Yoshida know that what his team would discover in the coming weeks would fundamentally challenge everything they believed about American industrial capabilities. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the story of how a small team of Japanese engineers and metallurgists came face to face with the overwhelming industrial might of the American war machine, and how their discoveries would transform not just their understanding of materials science, but their entire perception of what their nation was truly up against in this global conflict. The wing section had been recovered from a downed B-29 superfortress that had crashed in the mountains northwest of Nagoya following an engine fire. The aircraft had been part of the 21st Bomber Command's strategic bombing campaign. Though most of the fuselage had been destroyed in the subsequent fire, one outer wing section had broken free during the descent and landed relatively intact in a rice paddy nearly 2 kilometers away. A local farmer had reported it, and within hours, military intelligence officers had secured the site and arranged transport to Nagoya. Handle it with extreme care, Yoshida instructed the 6 laboratory technicians as they maneuvered the 4-meter section onto reinforced examination tables. Every scratch potentially destroys valuable information. Lieutenant Commander Hiroshi Nakamura, the naval officer assigned to oversee the examination, stood with his arms crossed at the back of the laboratory. Chief Engineer, the Imperial Navy expects preliminary findings within 72 hours. We need to understand how these bombers operate at such extreme altitudes. Yoshida nodded respectfully, but felt a flutter of anxiety. The Americans' new strategic bomber, the B-29 superfortress, had been appearing over Japanese cities at altitudes of 10,000 meters or higher, well beyond the effective ceiling of most Japanese interceptor aircraft. The inability to effectively counter these high-altitude bombers had become a source of significant concern for Japanese military leadership. "We will work around the clock, Commander," Yoshida assured him. "My team is the finest in the Empire." As Nakamura departed, Yoshida gathered his core team: Shigeru Tanaka, their materials specialist, Keiko Watanabe, their analytical chemist, and Ichiro Sato, their structural engineer. All 3 had been educated at Tokyo Imperial University and had worked together at Mitsubishi Heavy Industries before being drafted into military research. "This is unprecedented access to American aviation technology," Yoshida told them. "We must be methodical and thorough." He pointed to the gleaming wing section. "Tanaka, begin with material identification and sampling. Watanabe, prepare for alloy analysis. Sato, document every aspect of the structural design. I want detailed diagrams of the internal framework." The team set to work immediately, each bringing specialized equipment to bear on the mysterious aircraft component. For hours, they worked in near silence, the only sounds being the click of measuring tools, the scratch of pencils on paper, and the occasional whispered consultation. By evening, they had completed preliminary measurements and had carefully extracted small samples from various parts of the wing for chemical analysis. The team gathered around a small conference table in the corner of the laboratory to share initial observations. "The basic dimensions are remarkable," Sato began, spreading out his detailed sketches. "The wing is significantly longer and thinner proportionally than anything in our current aircraft inventory. The aspect ratio, the relationship between length and chord, is extraordinary. This design would provide exceptional efficiency at high altitudes." Tanaka nodded, "But what's truly surprising is the material consistency. My preliminary tests suggest this entire structure is made from a highly refined aluminum alloy. The purity levels are, well, frankly, they're beyond anything I've seen in aircraft construction." "That matches my initial findings," Watanabe added, consulting her notebook. The aluminum appears to contain specific amounts of copper, magnesium, and manganese that would give it remarkable properties, lightweight but incredibly strong, especially at the temperature extremes encountered at high altitude. Yoshida leaned forward, fascinated. And the manufacturing quality? That's where things become truly interesting, Sato said, his voice dropping slightly. The riveting is perfectly uniform, and I mean perfectly uniform. Every rivet, every seam, every connection point shows precision that would be nearly impossible to achieve with manual assembly. Are you suggesting automated construction? Yoshida asked. I cannot think of any other explanation, Sato replied. The consistency exceeds human capability. The team exchanged glances, the implication hanging in the air. Japan's aircraft were largely hand-built by skilled craftsmen. The idea of automated mass production on this scale was outside their industrial experience. Tomorrow, we begin detailed analysis, Yoshida decided. Tanaka, I want comprehensive material testing. Stress tolerance, temperature response, everything. Watanabe, complete chemical composition analysis of all samples. Sato, continue with structural mapping and run load simulations. As the others departed for a few hours of rest, Yoshida remained in the laboratory, circling the wing section slowly. He ran his hand along its smooth surface, noting the perfect curvature. Something about the component bothered him deeply, though he couldn't yet articulate what. The next morning, the team reconvened, each bringing increasingly sophisticated equipment to bear on their analysis. Tanaka subjected metal samples to stress tests, measuring precisely how much force the alloy could withstand before deformation. Watanabe worked with an emission spectrograph to determine the exact metallurgical composition. Sato created scaled models to test aerodynamic properties. By midday, Lieutenant Commander Nakamura returned, this time accompanied by Major General Takeo Takahashi from Army Air Headquarters. We require an update, Takahashi announced without preamble. A stern man with a reputation for technical knowledge unusual among senior officers, he was known to have the ear of several members of the Supreme War Council. Yoshida bowed respectfully and led the officers to their preliminary findings display. Sir, we are still in the early stages of analysis, but several significant observations have emerged. He gestured toward Tanaka's materials testing station. The aluminum alloy used in the B-29 wing construction is of exceptional quality. Our tests indicate tensile strength approximately 30% greater than our best aircraft aluminum, while maintaining similar weight characteristics. How is this possible? Takahashi demanded. The answer appears to be in both composition and manufacturing process, Watanabe interjected, stepping forward with her analysis results. The Americans are using precise amounts of copper, 4.5%, and magnesium, 0.5%, along with trace amounts of manganese and other elements. But more importantly, the metal has been subjected to a heat treatment process that creates a molecular structure we haven't previously achieved, Yoshida continued. Additionally, the construction methods suggest a level of industrial automation that— He hesitated, aware of the implications of his words. That exceeds our current manufacturing capabilities. The officer's expressions darkened. Are you suggesting, Engineer Yoshida, that Japanese technology is inferior? General Takahashi asked coldly. Not inferior, sir, Yoshida replied carefully. Our approaches are different. Japanese craftsmanship produces excellent aircraft suited to our tactical needs, but this wing represents a different manufacturing philosophy, one focused on standardization and mass production. Explain, Nakamura demanded. Sato stepped forward with his detailed diagrams. Sir, every rivet, every seam on this wing section is identical, spaced exactly 5.8 centimeters apart, set to precisely the same depth, with identical tensile strength. This level of consistency would require machine-driven manufacturing on a scale we haven't implemented. The officers exchanged concerned glances. How many work hours would you estimate went into this single wing section? General Takahashi asked. Sato performed quick calculations in his notebook. Based on our manufacturing methods, approximately 800 to 1,000 man-hours. However, with the level of automation this suggests, The Americans might be producing it in less than 200 hours. A heavy silence fell over the laboratory. "Continue your analysis," General Takahashi ordered finally. "I expect a comprehensive report in 5 days. This information is classified at the highest level." After the officers departed, the team redoubled their efforts. For the next 3 days, they worked nearly without rest, meticulously documenting every aspect of the wing section's construction. On the morning of the 4th day, Watanabe made a discovery that would change everything. "Chief Yoshida," she called from her workstation, her voice unusually animated. "You need to see this immediately." Yoshida hurried over to find Watanabe examining a small metal sample under a microscope. "I've been analyzing the crystalline structure of the aluminum," she explained, "and I found something remarkable. Look here." She stepped aside to allow Yoshida to peer through the microscope. "The metal has been subjected to a precipitation hardening process that's far more refined than anything we're currently employing," she explained. "But that's not the most significant finding. The aluminum itself, it's incredibly pure." "How pure?" Yoshida asked. 99.8%, Watanabe said quietly. Yoshida looked up from the microscope, stunned. That's nearly impossible with our current refining methods." "It gets more concerning," she continued. "Based on the trace elements present, this aluminum was produced using massive amounts of electricity, far more than we allocate to our entire aviation metal production. The implications were staggering. To produce aluminum of this purity in such quantities would require enormous electrical capacity, the kind of industrial infrastructure Japan simply didn't possess." That afternoon, Tanaka made another critical discovery while examining the wing's internal structure. "Chief, there's something unusual about these support struts," he called to Yoshida. "They're hollow." Further investigation revealed that the B-29's wing contained an intricate system of hollow support structures, strategically designed to provide maximum strength with minimum weight. "This is brilliant engineering," Sato admitted as they examined the structures. "The Americans have created a component that's both stronger and lighter than anything we've developed. It's perfectly designed for high-altitude flight." As the 5th day of their investigation began, Lieutenant Commander Nakamura and General Takahashi returned, this time with another officer, Rear Admiral Michitaro Totsuka from Naval Intelligence. "Your report is due today," General Takahashi reminded them. "What have you determined about the Americans' technological advantages?" Yoshida took a deep breath before responding. "Gentlemen, our analysis has revealed several critical factors that enable the B-29 to operate at such high altitudes. The engineering is exceptional, but what's most significant is what this wing section tells us about American industrial capacity." He gestured to a comprehensive diagram Sato had prepared. "The aluminum used in this aircraft is refined to a purity level that would require approximately 4 times the electrical power we currently allocate to our entire aircraft industry. The alloy composition and treatment process suggest metallurgical techniques we have not yet mastered, and most importantly, the manufacturing precision indicates automated production methods that dramatically reduce construction time while maintaining exceptional quality." Admiral Totsuka stepped forward, his expression grave. "In practical terms, Chief Engineer, what are you telling us about the Americans' capability?" Yoshida looked at his team, then back to the officers. "Based on our analysis, Admiral, we believe the Americans can produce B-29 bombers at a rate of approximately 4 to 5 times what we could achieve with a similar design, even if we had the technical specifications. The resource allocation alone, especially the electricity required for aluminum production of this quality, would be beyond our current industrial capacity." A heavy silence fell over the laboratory. "How many of these aircraft do you estimate they could produce in a year?" General Takahashi asked quietly. Sato consulted his calculations. "Based on the manufacturing evidence, and assuming their industrial base remains undamaged, between 1,000 and 1,500, sir." The officers' faces remained impassive, but Yoshida could sense their shock. Japan's entire aircraft production for 1943 had been approximately 16,000 planes of all types, most of them much smaller and less complex than the B-29. The resource requirements for 1,500 superfortresses would be astronomical. "There is one more thing, sir," Yoshida added, deciding complete honesty was necessary. The wing design itself, the aspect ratio, the hollow supporting structures, the materials, all of it is optimized for operations above 10,000 meters. Our current interceptor aircraft struggle to reach 8,000 meters with sufficient performance capabilities. Even if we could identify these bombers, engaging them effectively would require entirely new aircraft designs. Admiral Totsuka nodded slowly. I understand. Prepare your full report immediately. This information must reach Imperial headquarters today. The next morning, as the team finalized their technical documentation, an unexpected visitor arrived at the laboratory, Professor Hideki Yukawa, Japan's leading theoretical physicist and a researcher who had worked extensively on military applications of science. Professor Yukawa, Yoshida greeted him with surprise and deep respect. This is an unexpected honor. I was asked to review your findings about the American aircraft, Yukawa explained, examining the wing section with evident fascination. Your report has generated significant concern in Tokyo. For the next several hours, Yoshida and his team walked Professor Yukawa through their analysis. The physicist asked penetrating questions about the materials, the manufacturing evidence, and the design philosophy. Your observations about their aluminum production are particularly significant, Yukawa noted. Do you know what's required to produce aluminum of this purity in such quantities? Enormous electrical capacity, Watanabe replied. Precisely, Yukawa nodded. The Americans have hydroelectric resources we can only dream of. The Grand Coulee Dam in Washington state alone produces more electricity than the entire Kansai region, and they have dozens of such facilities. He ran his hand along the wing's surface thoughtfully. This component represents more than advanced engineering. It represents a fundamentally different industrial capability, one built on nearly unlimited resources and massive standardization. Later that day, after Professor Yukawa had departed, Yoshida gathered his team for a private conversation. I believe it's important we discuss the broader implications of our findings, he told them quietly. Not just the technical aspects, but what they mean for Japan's situation. You mean the resource disparity, Sato said flatly. Yes, Yoshida nodded. We've always known America had advantages in raw materials, but this wing section reveals something more fundamental. The quality gap is even more concerning than the quantity gap. Their aluminum is not just more plentiful, it's better, Tanaka agreed. And their manufacturing precision exceeds ours, not because their workers are more skilled, but because they've developed production systems we haven't yet implemented. Or perhaps cannot implement, Watanabe added quietly. The electrical requirements alone for this kind of aluminum production would require infrastructure development that would take years. The team fell silent, each contemplating the implications. What happens to our report now? Sato finally asked. It will reach the highest levels of government, Yoshida replied. Beyond that, I cannot say. The following week, their analysis complete, the team was preparing to return to their regular duties when Lieutenant Commander Nakamura appeared with unexpected news. You're being reassigned, he informed them, by direct order of the Technology Development Board. You're to report to the Nagoya Aircraft Research Institute immediately to begin work on a new high-altitude interceptor program. All of us? Yoshida asked, surprised. Yes. Your analysis of the American bomber has been deemed critical to national defense. You'll be working with designers from Mitsubishi and Nakajima to develop countermeasures. The team was quickly relocated to a sprawling research facility on the outskirts of Nagoya. There, they found dozens of engineers and designers already at work on plans for a new aircraft specifically designed to intercept high-altitude bombers. Colonel Akira Yoshizawa, the project director, greeted them on arrival. Your B-29 wing analysis has completely altered our understanding of what we're facing, he told them frankly. We're now redesigning our entire interceptor concept. The research facility was impressive. Japan's best engineers had been gathered, and resources seemed, for the moment at least, plentiful. Yoshida and his team were given a dedicated laboratory to continue their materials analysis while collaborating with the aircraft designers. Within days, however, the fundamental challenges became apparent. Japan simply lacked the industrial capacity to match the materials quality they had identified in the American aircraft. Every design compromise to accommodate Japanese aluminum resulted in performance reductions. 2 weeks into the project, Yoshida was summoned to a high-level briefing attended by senior military and industrial leaders. To his surprise, he found himself facing members of the Supreme War Council's Technology Assessment Committee. "Engineer Yoshida," began Admiral Soemu Toyoda, "your report on the American B-29 has raised significant questions about our industrial competitiveness. Some have suggested your assessment is overly pessimistic. Do you stand by your conclusions?" Yoshida straightened his posture. "Admiral, my team's analysis was conducted with utmost scientific rigor. We identified specific metallurgical and manufacturing advantages in the American aircraft that would be extremely difficult for our current industrial base to replicate. This is not a matter of effort or commitment, it is a matter of industrial capacity and technological development. What would be required to close this gap?" asked a representative from the Ministry of Industry. "In the short term, it would be nearly impossible," Yoshida replied honestly. "The Americans' advantage in aluminum production alone would require us to triple our electrical generation capacity. Their automated manufacturing techniques would necessitate an entire retooling of our aircraft industry." His words were met with uncomfortable silence. Finally, Admiral Toyoda spoke again. "We are implementing a new strategic priority for interceptor development. You will be provided with whatever resources you require. Japan's technical ingenuity has overcome challenges before." Yoshida nodded respectfully, but privately harbored serious doubts. Over the following months, Yoshida and his team worked tirelessly on the interceptor project. They developed innovative compromises, lighter weight designs that required less high-quality aluminum, alternative materials where possible, and streamlined production methods that maximized Japan's strengths in skilled craftsmanship. The prototype that eventually emerged, the Nakajima Ki 87 Shinden, was a remarkable achievement given the constraints. With a planned service ceiling of 13,000 meters and specialized high-altitude performance, it represented the best of Japanese aeronautical engineering, yet Yoshida knew it was too little, too late. By the time the prototype was ready for testing in early 1945, American B-29 raids had intensified dramatically. The aircraft factories themselves were increasingly targeted, and critical aluminum supplies were dwindling. On a clear morning in April 1945, Yoshida stood with his team watching the first flight test of the Ki 87 prototype. The sleek interceptor climbed impressively into the blue sky, reaching test altitude in record time. "It's a beautiful aircraft," Tanaka commented. "Yes," Yoshida agreed, "but we'll be able to produce perhaps 40 or 50 before year's end. Intelligence estimates the Americans now have over 500 B-29s in operation against Japan." The implications hung silently in the air between them. As spring turned to summer, the war situation deteriorated rapidly. Yoshida and his team were eventually evacuated from Nagoya as American bombing intensified. Their research facility was relocated to a rural area near Mount Fuji, where they continued work despite increasing material shortages. In July, Yoshida received an unexpected visit from Professor Yukawa. "I've been reviewing the progress reports from your interceptor project," the physicist said after they had exchanged greetings. "The design innovations are impressive." "Thank you, Professor," Yoshida replied, "though I fear it represents a perfect aircraft that cannot be built in meaningful numbers." Yukawa nodded thoughtfully. "I've been thinking a great deal about your original B-29 wing analysis. It revealed something more significant than just aircraft technology, didn't it?" "Yes," Yoshida agreed. "It revealed the true nature of modern industrial warfare. Quality and quantity are inseparable at this scale. The Americans haven't just built better aircraft, they've built better factories to build better aircraft. There's a lesson there for Japan's future," Yukawa said quietly. On August 15, 1945, Emperor Hirohito announced Japan's surrender. For Yoshida and his team, the news brought complicated emotions, relief that the destruction would end, uncertainty about what would follow. 2 months later, Yoshida found himself in an unexpected position. The American occupation authorities, having reviewed Japanese technical research, had requested his team's assistance in documenting aviation technology developments. Their expertise was now considered valuable for peaceful applications. Their first assignment was, ironically, to provide a comprehensive assessment of Japanese aluminum production capabilities for civilian reconstruction efforts. The American officer overseeing the project was Major Robert Anderson, a metallurgist in civilian life who had worked at Alcoa, the aluminum company of America. "Your analysis of our B-29 wing section was remarkably accurate," Anderson told Yoshida during their first meeting. "Our intelligence teams found your report in Tokyo and were impressed by your team's insights." Yoshida was surprised. "You know about our research?" "Of course," Anderson smiled. "Good engineering is universal. Your identification of the precipitation hardening process was spot on. That technique was actually quite new even for us, developed in 1941 specifically for aircraft production." Over the following weeks, Yoshida and Major Anderson developed an unusual professional rapport, exchanging technical information that would have been unthinkable months earlier. "What amazed us most was your aluminum purity," Yoshida admitted one day as they reviewed production specifications. 99.8% was beyond our capabilities." Anderson nodded. "That was the result of the Tennessee Valley Authority, a massive government electricity project started in the 1930s. By 1943, we had dedicated over 10% of our entire national electrical output to aluminum production." 10%? Yoshida was stunned. "Our entire aircraft industry received less than 3% of Japan's electrical capacity." "It wasn't just quantity," Anderson added. "We completely redesigned the production process. At peak production, we were producing 60,000 tons of aircraft aluminum every month. The figure was staggering, more than Japan's entire yearly production." As their work continued, Yoshida found himself contemplating the profound lessons of the B-29 wing. One evening, as he walked with Tanaka along the Sumida River in Tokyo, he shared his thoughts. "The Americans didn't just build a superior bomber," he observed. "They built a superior industrial system. That's what we discovered in that wing section. Not just advanced metallurgy, but a fundamentally different approach to production." Tanaka nodded. "And now they're helping us rebuild using those same principles." "That's what fascinates me," Yoshida replied. "The very industrial efficiency that proved so devastating in war is equally powerful for reconstruction. The same techniques that produced B-29 wings can produce refrigerators, automobiles, and housing materials." 6 months later, Yoshida was offered a position with a newly forming research institute focused on industrial modernization. The position would allow him to help transform Japanese manufacturing using lessons learned during and after the conflict. Before accepting, he gathered his old team, Tanaka, Watanabe, and Sato, for a final meeting at their original laboratory in Nagoya, now partially rebuilt. "Do you remember when that wing section first arrived?" he asked them. "How certain we were that we would discover some secret technological advantage." They nodded, smiling at the memory. "What we found instead was much more significant," Yoshida continued. "We discovered that modern industrial capability is itself the advantage. The Americans didn't win because they had better scientists or engineers. They won because they had created systems that multiplied their technical capabilities. And now we have the opportunity to build those same systems," Watanabe observed. "Exactly," Yoshida agreed. The lesson of that B-29 wing wasn't just about aircraft design. It was about the society that could produce such components in vast quantities while maintaining exceptional quality. As they parted ways that evening, each heading toward new roles in Japan's reconstruction, Yoshida took one last look at the laboratory where they had made their discovery. The building was being renovated, modernized with efficient production lines based on American designs. In the years that followed, Yoshida would become an influential figure in Japan's industrial transformation. The lessons learned from that single B-29 wing section, the importance of standardization, precision manufacturing, and materials science, would help guide Japanese industry toward becoming a global leader in quality and efficiency. By 1965, 20 years after examining that wing section, Yoshida would serve as an advisor to Sony, Toyota, and other emerging Japanese industrial giants. The manufacturing principles he had first glimpsed in that American bomber component had been adopted, refined, and ultimately improved upon by Japanese companies. On the 20th anniversary of the war's end, Yoshida received a letter from Robert Anderson, his former American counterpart, now an executive at Boeing. The letter contained a photograph of a new commercial aircraft wing being manufactured, a Boeing 727, along with a brief note: "From bombers to airliners. The same principles at work. Thought you might appreciate seeing how that B-29 wing evolved." Yoshida smiled as he studied the photograph. The precision, the materials, the manufacturing techniques, all had advanced tremendously, yet still contained echoes of what his team had discovered in that laboratory in Nagoya so many years before. That evening, he wrote in his journal, "The true lesson of the B-29 wing was never about warfare at all. It was about human ingenuity and the power of organized, systematic production. The same principles that enabled that aircraft to fly at heights we couldn't reach have now helped Japan rise to new heights of peaceful prosperity. Perhaps that is the most important discovery we made, that technology itself is neither good nor bad, but rather a reflection of the society that creates it." And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.